Completing the square is a process where we take a trinomial and we try to factor it into a binomial squared. So in the example that they've shown right there, in this example, they've got a perfect square trinomial right here. So x squared plus 12x plus 36 is a perfect square trinomial. It's x plus 6, x plus 6. If I take x squared plus 10x plus 25, that's a perfect square trinomial. X plus 5, x plus 5. If I take x squared minus, let's see, 8x plus 16, that would be x minus 4, x minus 4. And then of course, when you have something times itself, you can write it raised to the second power. So you can hopefully see where we're going with this. If we have a perfect square trinomial that we can rewrite as a binomial squared, we're going to be able to go back and make it look like this problem right here. We'll be able to make it look like this problem, and then we'll be able to square root both sides and solve the problem. The deal is, how do we take something that's not already a perfect square trinomial, like x squared plus 12x plus 32, and make it look like the perfect square trinomial that we need? Well, we already know that that 32 needs to be a 36, but if we didn't know that off the top of our heads, what process would we go through? Well, step one is to keep the quadratic and the linear term on one side. So I've got x squared plus 12x on one side of the equation, and I want to get the constant on the other. If x squared has a leading coefficient, then we would factor that value out. It doesn't, so we're ready to complete the square. Completing the square is this process right here in blue. To complete the square, you take half the linear term. So 12x, half of 12 is 6. You're going to take 6 squared and put that value right there. Now you have a perfect trinomial, a perfect square trinomial. But if I add 36 on the left side, I have to add 36 on the right-hand side of the equation to keep everything balanced. Now I can rewrite x squared plus 12x plus 36 in its factored form, x plus 6 quantity squared equals 4. So we balanced right there, and now we factored, and we're going to square root both sides. When we square root both sides, we get that plus or minus. So we get x plus 6 equals plus or minus 2. That means x plus 6 equals negative 2, and x plus 6 equals positive 2. Subtract 6, and we get x equals negative 8. Subtract 6, and we get x equals negative 4. And those are our two answers. We're going to try some more. Here we have 3x squared minus 12x minus 7. So remember what that first step was. That first step is to get the quadratic and the linear term on a side by itself and add the 7 to the other side. So add 7 to both sides to move it to the right. Now because I have a leading coefficient, I need to factor that out before I complete the square. So I factor that out and I get x squared minus 4x, and now I'm going to be able to complete the square. In fact, I'm going to leave a little bit of room because I want to do something cool here. Okay. Half of 4 is 2. 2 squared is 4. Now I didn't just add 4 to the left-hand side, I added 12. 3 times 4 is 12, so that means I have to add 12 to the right-hand side. So we've got 3 times the quantity, x minus 2 quantity squared equals 19. I'm going to divide both sides by 3. I get x minus 2 quantity squared equals 19 thirds. We're going to square root both sides. I get x minus 2 equals plus or minus the square root of 19 over the square root of 3. I'm going to rationalize that denominator. So I get plus or minus the square root of 57 over 3. So adding 2 to both sides, I get 2 plus the square root of 57 over 3. Now 2 is not over 3, so the fraction is just the second term, and x equals 2 minus the square root of 57 over 3.